Okay, we are in the video 2 of the topic retaining wall and earth pressure. So let us begin with the types of earth pressure and its development. Now, with the movement of the wall away from or towards the backfill, a portion of the soil mass represented as a vase, triangular vase, tends to fail either in expansion or in compression. The soil under such conditions exerts lateral pressure on the wall, which is known as earth pressure. Right? Therefore, the earth pressures are of 3 types. That is active earth pressure, passive earth pressure, and earth pressure at rest. Now one by one, let us handle active earth pressure. When the wall moves away from the backfill, the lateral pressure goes on decreasing and finally undergoes failure. The vertical pressure, that is gamma D, remains unchanged. The failure is known as active failure, and the lateral pressure is known as active earth pressure, which is minimum. On the other hand, passive earth pressure, if we say, when the wall moves towards the backfill, the lateral pressure goes on increasing and finally failure takes place. The vertical pressure remains unchanged, that gamma D's remain unchanged. The failure is known as passive failure, and the lateral pressure then is known as passive earth pressure. Which is maximum? Active earth pressure is minimum, passive earth pressure is maximum. The third one is earth pressure at rest. Right? Now, there is an intermediate pressure situation such that the wall remains perfectly stationary. It neither moves outward nor it moves inward. When the wall remains perfectly stationary, at that instant, the wall is supposed to have earth pressure at rest on it. The wall does not move in either direction. The pressure that develops in zero movement of the wall is known as earth pressure at rest. The earth pressure at rest is definitely greater than the active earth pressure and smaller than the passive earth pressure. Because active earth pressure is the minimum, passive earth pressure is maximum, so earth pressure at rest has to be in between these two. Right? Okay. Now the magnitude of the passive pressure, active pressure, and at rest pressure, depending upon the movement of the wall, can be well understood by this figure. Go. This is the movement leftward, rightward, both ways the wall moves. And the height represents the pressure, magnitude of the pressure. Now this is the highest pressure is passive pressure, PP. The lowest pressure is active pressure, and when the wall is not moving, that is in zero movement, this is earth pressure at rest. Earth pressure at rest. So now we know there are 3 types of earth pressure: active earth pressure, passive earth pressure, and earth pressure at rest. Now we are duty bound to learn the technique how to find the determination of the magnitude of the different types of earth pressure. Let us handle one by one. Let us begin with active earth pressure at rest. The process of determining the active earth pressure at rest. Now, determination of determination of earth pressure at rest. Consider a soil element. Consider a soil element subjected to pressure from all the directions. That means a soil element within the ground level is supposed to be subjected to forces from all directions: vertical direction, horizontal x direction, and horizontal y direction. Let these forces are sigma 1, sigma 3, sigma 2. But because sigma 2, sigma 3 are both come from the surrounding soil, they are supposed to be equal. So write sigma 3 and sigma 3 both instead of sigma 2. Whereas sigma 1 comes from the overburden pressure, which is nothing but it is gamma D, overburden pressure. Sigma 3 are surrounding pressure. Right? Now the element which is subjected to forces in three directions can be analyzed as following. The strain in any one direction, say x or y, say x direction, will be sigma x will be 1 by E sigma 3 minus mu sigma 1 plus sigma 3. Check it. Where mu is the Poisson's ratio. Now, at rest condition, because there is no movement of the wall, the element will not be compressed or elongate. So strain will be 0. That is, sigma x will be equal to 0. That means this equation will be equal to 0. That means E will go to 0. That means sigma 3 minus or equal to mu sigma 1 plus sigma 3. What we want is, we want the lateral pressure. That means sigma 3. Let us open it. 1 plus mu sigma 3, taking this side and taking sigma 3 is out. 1 minus mu equal to mu sigma 1. So sigma 3 is mu sigma 1 by 1 minus mu. This sigma 3 is actually the side pressure or lateral pressure. So we have found the lateral pressure. So this is lateral pressure, means that is right P not at rest, means I write 0. Now onwards lateral pressure will write small p, and for 0 it is at rest pressure. So this becomes the at rest pressure. Now we have been able to derive the formula for earth pressure at rest as this: P0 is equal to mu sigma 1 by 1 minus sigma 1, 1 minus mu. Here sigma 1 is the vertical pressure, which is gamma D. Gamma D by 1 minus mu. Now if you look at this one, this factor, this consists of only Poisson's ratio, where this other factor gamma D is variable. It varies with the depth and also is varies with the density of the type of the soil. Okay. Now for this factor, if I write P0 is equal to giving a new name K0 gamma D, then K0 will be called coefficient of earth pressure at rest. Coefficient of earth pressure at rest will be symbolized as K0, which is mu by 1 minus mu. Then earth pressure at rest at any time will be simply K0 gamma D. K0 gamma D. Where gamma is the unit weight of the soil, unit weight of this backfill or soil, D depth at which earth pressure is required, P0 is required. Now it is seen from the earth pressure at rest equation 1 that the earth pressure at rest varies with depth D and it varies linearly. If you intend to draw a earth pressure diagram, earth pressure distribution diagram along the height of the wall, it is going to be a diagram like this. Suppose this is the the top of the ground level. Then the earth pressure at rest varies from 0 to maximum, 0 at the top, maximum at the bottom. If this is the height, along the height, the pressure increases from 0 to 0 at top and maximum at the bottom. According to the formula, at top, the earth pressure at rest P0, as it is K0 gamma D, so it will be 0 because D is equal to 0 at top. And at bottom, P0, again K0 gamma D, it is actually K0 gamma H because D is equal to H. So at the bottom it is K0 gamma H and at the top it is 0. So the stress distribution diagram is now shown like this, which increases from 0 to maximum and varies linearly. Now that we know the formula to find the earth pressure at rest, that is P0 is equal to K0 gamma D, we should learn how to apply this formula to find the earth pressure at rest and to determine and to solve the problems. Let us solve one problem to make things clear. Right? Let the question is example 1. Determine the earth pressure at rest along the distributed along the height of a retaining wall with vertical back face and backfill with unit weight 18 kilonewton per meter cube. Poisson's ratio, that is mu is equal to 0.4, whereas while the height of the wall is 6 meters. Now in this question, if you draw a figure, 6 meter high wall, there is backfill on one side. The data is, you can write itself here, 0.4, and gamma is equal to 18 kilonewton per meter cube. Generally, you can write here solution. After drawing figure, write the data. Mu is equal to 0.4, gamma is equal to 18 kilonewton per meter cube. After writing mu, first write K naught. We know Q naught is equal to mu by 1 minus mu. That would be 0.4, 1 minus 0.4, that is 2 by 3. Right? Now our earth pressure rate formula gives you P naught is equal to K naught gamma D. Now this formula will be applied from top to bottom of the vertical wall. From the top to bottom, there is only two salient points, top and bottom. There is no intermediate points where the earth pressure is supposed to be changed. It varies linearly from top to bottom uniformly. So only at point top and at bottom we'll find and we'll join it. So at top, D is equal to 0. So P naught is equal to 0 over. At bottom, D is equal to how much? 6 meters. You can write the data here also. H is equal to 6 meters. D is equal to 6 meters. So P naught will be K naught gamma. This is 72 kilonewton per meter square. Now, if you intend to draw the diagram, distribution diagram, then the data is ready. At top it is 0, at bottom it is 72, so at bottom it is 72, at top it is 0, and it varies linearly, so we can join linear diagram. And now this is the stress distribution diagram. This is the stress distribution diagram. It is 0 and it is 72 kilonewton per meter. So with this, we conclude our video 2 of the topic retaining wall and earth pressure. The next is video 3 that will bring you the method to determine the active earth pressure. Okay.